Hey everybody, this is Alex Merced from alexmercedcoder.com. This is another video on the C language. This is probably going to be the last one I do in the C language for a bit because I want to go play with some other languages. But this one's going to kind of get into some of the sort of things you always hear about if you're not a C programmer that you're like, oh, that sounds not fun. And it isn't. Things like dealing with memory allocation. Um, and working with arrays. Like if you ever work with arrays in JavaScript, they're just delightful. You can do whatever you want with them, and they have all sorts of built-in methods. And then if you go into like Ruby or Python, they even have more built-in methods. Um, in C, you can make an array. Yep, that's about it. So pretty much any methods, any alterations to the array, an array, you have to create your own functions for. And there are several different libraries, but far as I could, from what I could research, there isn't really like a standard. As far as like what array library should I use to have functions like push, pop, things like that. The kind of things we're used to in higher level languages. Because again, C is like a very systems level language. It's just like an abstraction over assembly language. So you're getting pretty close to sort of bare metal here. Um, Now, one thing I do like about programming in C quite a bit is that it makes a lot of the things that you read about with data structures, whatnot, much more tangible because those things don't necessarily exist here. Like, for example, when you're using JavaScript, there's already things that kind of work like a stack or a queue. So you're like, why would I ever make a stack or a queue? Because there's already things in JavaScript that kind of work that way. I can already push and pop on an array. I can already, you know, simulate the behavior of a queue by first, you know, unshifting things into the beginning of the array and then popping them off the end. While here in C, you have none of that. So if you wanted to have something that worked like a stack, you have to make it. If you want something that works like a linked list, you have to make it. Which then makes the whole idea of building these data structures more practical, a lot more difficult, because when you're building them in JavaScript, you can lean on a lot of things that kind of already have that functionality. Here, you really have to like painstakingly build it out. So, as an example, let's see here. I think it's in this file here. I wanted to build the push method, like basically be able to push an element into an array. Okay, so let me just walk through what I did here. Okay, because this was a lot of work. Just to do this. So I'm creating a function. Okay, and this function returns a pointer. Okay, so this function is returning a pointer, which is really it's returning a pointer to an array. That's sort of the point of this function. Okay, and at the end of the day, all arrays are pointers in C, or actually in all programming languages, because when you really think about it, an array or any other kind of data structure is just a sequence of or a block of memory. It's not an actual value. Like the number 2 is an actual value stored in memory. The the letter I is a value stored in memory. Booleans, which are just zeros and ones, are values stored in memory. The big difference is an array isn't a value stored in memory, is just a sequence of values stored in memory. So the array is never really an array, it's just an array that points to where the array begins and the array ends where there's like, and that was another thing that took me a second to kind of appreciate, is that let's say I have an array of 5 items, the array is actually 6 long, because technically under the hood there's this 6 spot that designates like the end of the array, and that's the extent of it. It's just a sequence of memory. You point to the first spot, and the array exists up until you get to the last spot. Although sometimes when you're working in C, it doesn't even know that you went beyond the scope of the array. You create an array, it allocates a certain level of memory, and then you just assign data to it, and you can keep assigning data to it. And then you might create all sorts of weird memory issues. So like the memory management is very, very manual. You have to be very, very careful, is my point. It's not like, I make an array in JavaScript. I can really assign anything to any index I want. Or even in like Go, if I assign something to a value of the index beyond the end of the index, it will shoot me a pretty clear error like, nope, you can't do that. Although C's error is actually pretty decent, I must say. I really do like the error handling of the C compiler because it gives you pretty clear errors. But back to this method. So this method, this function is taking 3 arguments. It's taking an array, because again the point is to push a value into this array. Okay. Push. Well, I want the length of the array, because that's another fun thing. You can't just like the way you have to get the length of array is actually let me go down here. This is how you get the length of an array in C. You have to use a size of operator. And with the size of operator, it gets you the size of the thing that you're pointing to. Okay, so if I point to the size of the array, it's going to grab the size of the memory from the point that I pointed to where the end array ends. So it gives me like the size of the array. And again, it doesn't count that last ending character. So it will return me the number 5, even though really there's 6 spaces in memory that are being used. And that technically this just returns me the size of the memory block. So what I have to do is divide it by the size of one element in the item. So basically, since this is an array of integers, when I do size of the R in the first index, it's getting me the size of an integer because it allocated the memory necessary for an integer. Because again, different data types need different amounts of memory. So this allocates the amount of memory for an integer, or like that's what this is. So essentially we're saying, okay, this amount of memory divided by the size of an integer should give me the number of items in the array. And this is going to end up equaling the number 5 because there's 5 elements in the array. Doesn't count that last blank spot. Okay, so that's not too bad. It's not the end of the world. Okay, I get it. But here's the problem. You can't use size of on an array you pass in as an argument, because originally I didn't want to have length as an argument. Okay, that is kind of a little clumsy. What I have to do, so what I wanted to do is you pass in the array, and then I do that whole size of logic in here. But you can't do that. You can't use the size of operator on an array that you pass in as a function, because technically the array, once it's inside the function, from my understanding, is that it no longer really recognizes the array as a value. It's purely just a pointer, so it's just seeing the address. So, which that was kind of weird. So theoretically, what I'd have to do is I could loop and create a new array just to creating, because you can't just like say, hey, this new array equals this old array. Not that simple. I'd have to loop over the old array to make the new array. But to loop over the array, I still need the length. So there really wasn't a way to kind of get around the whole idea that I need to determine the length of the array before the function begins. So I had to add this argument for length. So that was fun. Okay, so arrays are not quite so elegant in C, but again, that's just generally how this language works. And then you can add a new integer to this array. So again, this is built just for integer arrays. If I wanted to do a character array, I didn't have to rebuild this for characters. And if I wanted to do any other data type array, I'd have to rebuild this for that data type. Fun times. Okay. So that's fun. Okay. And let's see here, new item. Okay. So that's where we get the size, the length. So basically what I'm doing is I'm making a new array pointer, because again, this returns an array pointer. And then I'm getting a new length, because the new length of the array is, if I'm adding one item, I can't just add, the length is 5. And again, the length doesn't count the original blank spot at the end. So I have to add one spot for the new piece of data and one spot for a blank. I originally had one, but then I was getting all sorts of like errors, and it was because I wasn't giving it a spot for like the ending marker. So I have to add 2 spaces. So I'm adding 2 spaces to the length. And then the thing is that I can't just create a new array, which is what I originally did, because if you create a variable within a function, of course it's a local variable. That's pretty typical in most languages, meaning it only exists for the scope of the function. But in a lot of other languages like JavaScript, I can return the value of the variable, and I can basically pass that variable reference outside, and that variable, that scope, will just exist for as long as that reference exists. This is the whole idea of like closure in other languages. That's apparently not a thing in C. If it's declared locally, it exists locally. No ifs, ands, or but about it. From my understanding, is because the memory allocation in a function is purely on the stack, and the stack is going to be temporary. Okay, so as soon as the stack is complete, it erases any memory it uses. So once the function is complete. Versus if I use this malloc function, which stands for memory allocation, this allocates a piece of memory on the heap, which means it'll exist for the remainder of the process. Okay, so basically, instead of just creating a new array and assigning the pointer to this new array, I have to assign a block of memory that's the size of the array. So I want the new length, I want 7 spots, and each of those spots need to be size of 1 integer to create my array, my congruent block of memory. So that's what happens there. Cool. That was fun. So then I do a for loop. For loops are pretty straightforward, just like every language for the most part, for the exception of like Python, which doesn't have these kind of for loops. There's a couple. I think there's 1 or 2 other languages that don't. But basically, you have, what I'm doing here is I'm just rebuilding the part of the array that's the old array. So I loop based on the original length and assign the old value to that index in the new array. Once that loop is done, I assign the new value to the next index, which should be just the same number as the length. And then that's that. Okay, so in that case, in this case, if I add 1 to this 5-element array, I've assigned 6 spots, because index 5 is technically the 6th spot. And then I return the new array. Again, I'm not returning the old array, I'm returning the new array, which is a pointer to this memory that we allocated. And whenever you allocate memory, that memory exists until you get rid of it. So you want to make sure that when you're not using it anymore, you free it. So I use the free function and say, hey, that memory, because again, that block of memory is being assigned to this variable, because this function is running. So I'm passing it the value of 6. So I'm saying, okay, this array that I declared here, I want to add, it has 5 spots, and I want to add the number 6 at the end. Okay. And in that regard, I need to, since this returns a pointer, not an array, I need to assign it to a variable that's a pointer. So that's why this array, this equals, and I can reassign it, but I have to reassign a pointer. So that's 6, and if I want to, we can just do that logic again. So just to kind of see this in action. Actually, I just want these 3 lines. Okay, so let's try this again. 7. Although we'll need to get the size of the array again. Well, first let's just show you that it works. So let me comment out this line. Okay. We'll run the code. I'm wrong folder again. CD exercises. Okay, and so let's just walk through this. So that first 6 is a 6 that says, okay, what's the new item? The new item is 6. What's the new length of the array? Or what is in that new spot in the array? 6. Good. So that means I took the new value and I've added it to that next spot. Good. Okay. Then the next 2 prints are, am I testing that the 6 is there? The 6 is there. And just testing that I had the original length, which is there. Okay, so that works. Okay, but see, like that's a lot of work. Okay, and it's still kind of cumbersome because let's see what happens if I try to use it again. I want to put something else in that array. See, I need to get the array again, and I need to get the length again. And the thing is, I can't just pass. Um, let's try to pass an array. Okay, so the second time I'm going to pass an array. And I know the array length is 6, so I could just pass 6, but I don't want to do that. I want to do this programmatically. So I'm going to copy this logic. So in this case, before we pass that in there, I want to reassign the r length. But except this time, I want it to be measuring the size of an array, which I don't think will work. Which then presents like a whole other like thought process. Let's see. Oh, did it work? I think it did. No, wait. Okay, so see, this is interesting. Let's walk through it. Okay, so the first time the function runs, that all went hunky-dory. Okay, now the problem becomes, so when I pass in the array, 7, good, and the new array length is going to be 7, so I put 7 in the spot that I specified. But the problem is, let's take a look. I got a 0 when I printed out this spot, which actually should have probably been this spot this time. So it was worth 0, and the length is 2, because I'm not measuring the length of the array anymore. I'm measuring the length of the pointer. Okay, and that's not quite as useful. So then how do I get the measure of that array? Let's try something like that. Let's see if that does it. Nope. Now the address is just 1. The size is just 1. So that's where it gets really complicated. Like, okay, I got it where I can push something into an array once, but now I don't have I don't have an array to make use of to get the length of the next go around. So technically, what a lot of people end up doing is they end up creating a struct. From when I was reading, they'll create a struct, and the struct will have the array itself as one piece of data, and the length as another piece of data. So that way, when it returns you the data, it's returning you a pointer to a struct, and that struct is going to have not just the array data that you just added, but the new length. So that way, it can keep doing these operations. Yeah, and that's probably how it's implemented in other languages under the hood. But just so you can see, like, that'd be a lot more work. Because first I have to go implement the struct, and then I have to do all this logic based on a struct. So hopefully, you kind of appreciate like some of the complexities of working with C, and that it is tricky. It is work. But again, you have this very granular control of how memory is allocated because of it. But with that comes a lot more verbosity of what you need to do here. Okay? I mean, technically, if this language was perfect, there would never been any other programming languages afterwards. C would have been it. So, but it's been fun. It's been a fun adventure this week, just kind of playing around with C and getting a feel for what C can do. And now I have a better idea of sort of like, because a lot of compilers are written in C. Like compilers for other languages are oftentimes written in C. So getting an appreciation for like the level of granularity they had to do to implement those things that we take for granted in other languages has been useful, has been instructive. But I'm not currently a systems developer, so I'm going to move on. I'm probably going to maybe spend another next week in C++, and just kind of keep going that way. I do want to spend some time with OCaml and Rescript. I want to spend some time with BOSC, which is a new language by Microsoft. So we'll see. But, subscribe to the channel. Alex, just click on the subscribe button. and join the Slack and Discord community over there at devnursery.com. Have a great day and enjoy. I'll see you guys later.